Hello everyone, welcome to this presentation entitled Exterior Environment Model. I am Sachin Tripathi from University of Connecticut and will be speaking on behalf of Murali Krishnan from Purdue University and myself. The overview diagram of modular coupled virtual testbed is shown in this slide, which consists of highly interactive subsystems, and exterior environment is one of them. The exterior environment model provides the meteorite impact, ground motion, and solar radiation information to structural system and provides the dust accumulation information to power and eclipse subsystems. The external environment model presented here includes solar radiation model and dust deposition model. Solar radiation model. The main function of solar radiation model is to determine the solar flux intensity, and these values is outputted to structural thermal model for thermal analysis and power generation model to determine power generated. Going into the physics, the dome structure is divided into several small elements based upon the solar angle of incidence theta I, which is the angle between solar ray vector and normal unit vector at that specific element. The solar flux intensity can be determined by using the equation which is given in this slide. This slide consists of solar radiation animation plot. During the sunrise, the base elements facing east will receive maximum solar radiation intensity as sun rays are normal to the surface. Then, as the sun rises at solar noon, we can see that the base elements will receive the minimum flux and the top will receive the maximum flux. Similarly, during the sunset, the base elements due west receive the maximum flux and the east part receives no radiation as shown by the blue region in this plot. Dust deposition model. The main function of this model is to determine the dust deposition rate, which goes as an input to both the power and eclipse subsystem. It can further be divided into exhaust event model for exhaust events and constant rate model for meteorite impacts. The dust deposition model presented here is obtained from Kazan et al., which estimated the lunar dust accumulation caused by engine plumes based on the best available estimate from the Surveyor 3 return components. The model estimates the amount of dust accumulated at a specified distance from a landing module for each exhaustive event. The model for dust deposition, denoted by tau, closely resembles with the gamma distribution. There are two separable terms in this equation. The first term provides the total amount of dust distributed by an event, and the rest represents the distance traveled by the dispersed dust particles. Finally, we present the model calibrated with values as per model number 2 presented by the paper. This is the specific model used to model dust deposition due to exhaust event in MCVT. We also model two additional terms to dust deposition, which are user specified constant value for dust deposition rate. This is to specify the nominal dust deposition rate and the deposition rate which is active during the meteorite shower. Both are constant values which get added into the dust deposition faced by components due to engine exhaust. The diagram here shows the dust accumulation rate during an exhaust event which occurs from 10 to 15 seconds. Thank you very much.